And this question it is given that a body is floating in water at 4 degrees Celsius such that 0.98 of its total volume is immersed in water. So in this question it is given that there is an object which is floating on the surface of water, and so whenever an object is inside a liquid or water, this liquid is going to exert some force which is known as nothing but upthrust or buoyant force. The equation for buoyant force is volume of object inside the liquid into density of liquid into acceleration due to gravity. Other than that, we can say that weight of this object mg is going to act in downward direction. Now in question it is given that if coefficient of real expansion of water is 3.3 into 10 raised to minus 4, means coefficient of real expansion means the value of coefficient of cubical expansion or the value of gamma, which is given as 3.3 into 10 raised to minus 4. The temperature at which the body gets immersed completely is Rm is to find out the temperature at which the entire object is going to get immersed in water. So over here we can just find out what about the current density of this object. To find out the density of object, we can use a concept that when it is in floating, the net force acting on this object is 0. That means force exerted by the buoyant force in upward direction, that is volume of object inside the liquid into density of liquid into acceleration due to gravity, is equal to the weight of this object, which we can take it as nothing but mg. Now in question it is given that volume of object inside the liquid is 0.98 times the volume of object into density of liquid, means it is density of water, into g is equal to, we can take it as, this mass of object can be written as density of object into we can take it as mass density into volume, so volume of object into g. So we can cancel this g over here and over here, volume of object and volume of object. So we'll get the value of density of object is nothing but 0.98 times the density of water. So currently the density of object is less than density of water. That's why this is going to like this object is going to float in water. Now the condition for sink is nothing but when the density of object becomes greater than density of liquid, or when the density of object is just equal to density of liquid, then it is just going to immerse in water. So you can write the condition that when the density of water becomes equal to density of object, that is equal to 0.98 times the current density of water, then that object is going to sink in water. So we can use the equation for density or variation of density with respect to initial density, that is final density is equal to initial density into 1 minus gamma delta t. So in this equation we can write the final density should be equal to 0.98 times of density of water, and initial density we can take the current density of water into 1 minus gamma into delta t. So from here we can find out the value of this delta t. So this gamma over here and over here density get cancelled. So we can write this as nothing but gamma into delta t is going to be 1 minus 0.98, which we can take it as nothing but 0.02. So the value of delta t can be written as nothing but 0.02 divided by gamma. So we can write this as 0.02 divided by the value of gamma. It is given in question as nothing but 3.3 into 10 raised to minus 4. So we can write this as 3.3 into 10 raised to minus 4. So we can write this is equal to 0.02 divided by 10 raised to 4, which can be written as 0.02 into 10 raised to plus 4 divided by 3.3, or you can write this as equal to nothing but 200 divided by 3.3, which is nothing but 60.60. So this is the value of delta T. So the current temperature should be equal to initial temperature plus the value of change in temperature. Initial temperature is given as nothing but 4. So we can write 4 plus 60.60, which we can take as 64.6. So if you are using this type of analysis, we may get the answer as in like 64.6. So you can approximately mark the answer which is near to that, which is 65.8. Now if you want to find out the exact answer without any approximation, so we can use that equation also, that is without any approximation equation, that is density is equal to initial density divided by 1 plus gamma delta t. So assume that if you are using the actual equation, so we can write this as 0.98 times of initial density is equal to initial density divided by 1 plus gamma delta t. So we can write this one and this one get cancelled. So we can write this 1 plus gamma delta t is going to be 1 divided by 0.98. So if you are going for the actual analysis, so we'll get as 1 plus gamma delta t is equal to 1 divided by 0.98. You'll get something like 1.0204681, something like that. So we can write this gamma delta t is going to be 1.0204681 minus 1. So we'll get around 0.020464681. So again, this is the value of gamma delta t, and if you want to find out the value of delta t, we can write this as 0.0204681 divided by the value of gamma. The value of gamma is nothing but 3.3 into 10 raised to I think the question is given that gamma is 3.3 into 10 raised to minus 4. So 3.3 into 10 raised to minus 4, thus we can take it as nothing but 204.681 divided by 3.3. So we'll get the value of delta t as around 61.84. So this is more accurate value. So we can find out as the delta t is this much. So we can find out the value of t, that is initial temperature plus change in temperature. So initial temperature is 61.84 plus change in temperature, we can write that is equal to 4. So change in temperature 61.84 and initial temperature 4, then you will get the answer as around 65.85. So this is more accurate value as compared to the initial calculation.